Okay, evaluating inverses leads us to this kind of problem where we have to evaluate the derivative of the inverse. Now, suppose we have g of x at 3x raised to 5 plus 4x cubed plus 2x plus 1. And then we are going to evaluate the derivative of its inverse at x equals negative 2. Now, the formula for the derivative of the inverse is 1 over g prime of g inverse of x. So, first we have to find g inverse of x. Now, we can find it using this, but since we are evaluating, instead of going through the hassle again of finding the inverse, we can just equate this at negative 2. So how do we do this? Again, that is just simply g of x equals negative 2. So 3x raised to 5 plus 4x cubed plus 2x plus 1 equals negative 2. Now, 3x raised to 5 plus 4x cubed plus 2x equals negative 3. This would be difficult to solve for x. So, we're going to use a graphing calculator just to identify the value of x when this function is at negative 3. Okay, we plugged our function and this would be the graph. If we are going to zoom in, you can see there the approximation for the value of x as it goes nearer to 3. We cannot get exactly 3 because that would be very, very long. So just approximate it. We have negative 0.674946. So we already have g inverse of negative 2, which is negative 0.674946. Next, we need to find g prime of x. We have there g of x, g prime of x. This would just simply use chain rule and power rule. So 5 times 3, that is 15, x raised to 4, plus 12, x raised to 2, plus 2, and then of course that's plus 0, so there's no point in doing it. Next, we have g prime of this. So that's g prime of g inverse of negative 2, which is the same as g prime of negative 0.674946. This gives us 15 times negative 0.674946 raised to 4 plus 12 674,946 squared plus 2. If you're going to plug it in your calculator, you would end up with negative 6.579541. Substituting our obtained value, we have 1 over negative 6.579541. Our final answer would then be negative 0.151986.